Resonant pulse chopper part 2. We have seen the 6 modes of operation of the resonant pulse chopper in part 1. Please check the description. The link is given. In this video, we'll try to draw the waveforms for the current and voltages through the capacitor and the thyristor and the output voltage. The current through the capacitor IC1 will be 0 in the mode 1, and in the mode 2 it will reach minus Vp and get back to 0, and in mode 3 it will reach the Im and it will supply the current during the mode 4. In mode 5 it will comes back to 0. It stays at 0 until the next cycle, until the thyristor is triggered. Now the current through the thyristor T1 will be Im and Im until the mode 2. In mode 3 the current will reach to 0 and it stays at 0, mode 3, mode 4, mode 5 and in mode 6 until thyristor T1 triggers. The voltage across the capacitor will be Vc in the mode 1. At the end of mode 1, the voltage will be reversed in mode 2 to minus Vc. In mode 3, it will reach to minus V1. Mode 4, it will reach to the positive value of Vs. This is Vs. In mode 6, it will reach to Vc. Voltage across the thyristor T1 will be 0 as the current flows in mode 1 and mode 2 and mode 3. So when the current across the thyristor T1 will become 0, the voltage across the thyristor will be at minus V1. From here, the voltage is going to reach to the Vc during mode 4, mode 5, and it will stay at Vc. Now, the voltage output will be at Vs until the mode 3. At the end of the mode 3, it will reach to Vs plus V1. During the computation of mode 4, it will reach to 0. This voltage is V1 and it will stay at 0. In steady state condition, the Vc equals to Vs. Then the average output voltage V0 is given by, from the output voltage waveform, you can see that in total time t, Vs for the period kt plus Vs for the period of Tr plus Tx. Then for the period of Tc, V1 plus Vs by 2. Let us solve this. Vs k plus Vs Tr plus Tx of 1 by t, which is nothing but f, plus 0.5 Tc of V1 plus Vs, again 1 by t is multiplied by f. Now Vsk plus, take out the f common from this 2, then f of Tr plus Tx of Vs plus 0.5 times of Tc of V1 plus Vs. This is the output voltage V0. Although the circuit does not have any constraint on the minimum value of duty cycle k, in practice the value of k cannot be 0. The maximum value of k, max, is given by 1 minus Tr plus Tx plus Tc of f. Due to the commutation by resonant pulse, the reverse di by dt of the thyristor T1 is limited by the inductor Lm, and this is also known as soft commutation. The resonant reversal is independent of thyristor T1. However, the inductance Lm overcharges the capacitor C, and this will increase the voltage rating of the components. After T1 is fired, the capacitor has to reverse its charge before turning off the thyristor T1. This is an inherent delay in the commutation, and this limits the minimum turn-on time of the chopper. And the commutation time Tc is going to depend on the load current Im. These are the observations made from the resonant pulse chopper. If this video is useful, please like, share, comment.